Hi, everyone. Welcome to a quick demo of some of the examples from how our crunch works today. So I'm going to directly switch to the screen real quick and give you a lay of the land. This is the interface we are looking at. On the very left, you can see which data sources are connected. So we have Snowflake, BigQuery, Postgres, and an auto track that we have on our own end. We've also uploaded two CSV files, spend and customer details. For now, there are no variables, and the table of content is just a quick navigation. You are seeing some of the questions which you could directly get started with. We call it Magic Notebook, and you can of course start from scratch as well, but what we have done here is just typed in a query which is like create customer segments based on RFM, recency, frequency, and monetary way of analyzing. Now as soon as you hit enter, there's a bunch of things that's going to happen. So you will see that the system gets to the work and it's doing this observation, then writing some queries in between. You see it's writing another query, then another observation, another query, and we can actually wait for it. Like it's relatively very fast. As these the queries are being written, the tables are getting populated. You will also see variables become super useful for someone who is more familiar with SQL, but otherwise as well. And then by the way, we support like multiple warehouses and multiple language. So multiple warehouses I already showed you. You could also try R, Python, anything in here, and you'll see that the analysis is now done. Like the system did a whole bunch of things across the tables and it did an RFM analysis. But let's actually look at what happened, right? Like so here observation is that okay, before creating segments we need to calculate the total spend for each customers. That's fair. And then it's saying once we have the total spend we can think about how to segment. So I'm assuming the first query would be about calculating the total spend, and it's saying that okay, list price on standard cost will take a difference, and then basically that would be the total spend. And for that it's pulling on the transaction table and it's grouping it by customer ID. Okay, so we by the way, all of these queries that you are seeing, you can just edit any number in here and like again go on and run it. I'll actually show it to you as well a little later. So then it's saying that okay, I need to identify the last date of the transaction. Then it makes another observation saying that the last transaction date is this. Now we know the structure of transaction data, so from the first query it knows how the transaction table is laid out. It's now saying that I need to calculate recency, frequency, and monetary values, of course, because we asked it to do an RFM analysis. So it's saying we first calculate monetary and frequency value. Of course, recency is a different calculation altogether. So in here, it's going and saying that, hey, uh, only consider approved orders, which is pretty cool. And it goes and says that we have successfully calculated the frequency and monetary values. So you can see the data getting populated. By the way, it's not like the table is small. You're only seeing a few rows in here. There is, of course, many more rows. And then when you go in and see that it's now basically saying that we have already identified the last transaction date here. So it's going to use that and sort of look at like the recency, as in how recent was the order. And of course, it's the inverse. Like the more recent, the higher is the recency value. So the lower the recency, the higher is its impact. Then it's basically going and saying that the same thing that with the 30/12 2017 as the date, we'll calculate it. I'm assuming it writes the query for that, of course. And then you can see that it has merged it with the table, wherein like the recency is now in the same table as frequency and monetary values. So now the observation 5 is that we need to like basically rank, right? Because we said that hey, do a segmentation. So without a ranking is pretty useless. And then it's very interesting because it says that a common approach to RFM segmentation is to assign a score from 1 to 5, one being the lowest and five being the highest. Usually, these scores are assigned based on quantiles, 20% segments. Since SQLite does not have any easy way to calculate quantiles, we'll do a simple ranking to a certain segment. So it's telling you that this is not quantile based, but it's gonna basically just do a relatively simple segmentation based on maximum and minimum values. So the next query is going to be, of course, about that. And you can see that RFM value as count frequency. Yes, it's precisely doing that. But the observation here is then again, hey, we have seen that recency range is like 0 to 353, frequency is this. And now it's basically saying that we need to uh, basically define thresholds for what ideally would have been the first quantile, second quantile, and third quantile. So it just says that we'll do an approximate 20, 40, 60, and 80% of the range. And let's define the threshold to assign scores. So this is about assigning the threshold. Yes, looks about right. And in here, the next observation is that, so of course, like you see that the threshold is like whatever result it gets from the query, it just justifies it. Then it's about, hey, we need to basically assign scores to each customer based on their individual RFM metric. So now this is about saying that, hey, when recency is 70.6, then assign a score of 5. When recency is more than 70.6, then assign a score of 4, and so on, right? Like now, observation 8 is that the metric, the RFM score has been assigned to each customer. And now it simply needs to concatenate the individual RFM metric score. And then there is a SQL query 9, which is where it's basically again going and saying that the first step is to concatenate these scores to form a complete RFM segment. Okay, so this is about concatenation, and then you can see that there is this RFM segment creation, and then it goes and says that hey, we have been able to create the segment. Now, before I jump into it, like let me actually show you something where I can edit. So if I edit it at the top, it's again going to rerun the query. So maybe we'll pick the last query and just see what we can edit in here. Maybe let's just go with something for the sake of demonstration. So I'm just going to click on 5 and then make it 6, and then I need to go to the top and run it. Now you see there is a new query that's being run, and the whole analysis, like of course 6 doesn't even make sense because we just talked about 5 quantiles, uh, but you get the idea, right? Like, so essentially what ended up happening is that the system followed a causation, right? Like it went from the first step, it told you what it's doing, why it's doing it, then it showed you the query for it. Of course, these queries are editable, you have full flexibility in terms of language. Now there could be various use cases. This is just one example of an agent that's been developed to study spend analysis and customer segmentation tables, and to sort of come up with like better customer segmentations. But these agents can be purpose built to do whatever you want them to do. So for example, you could go in and say, hey, uh, tell me who is more likely to churn. If you're looking at churn prediction, you could be a SaaS player and you may be looking at renewals, but you may just want to identify a pattern saying users who have done X, what are the other things that they're doing? So you can basically train the model to do whatever you want. And that's where it's very interesting, because an analyst is spending 99% of their time doing one of these three things, right? Like first, they're either just running regular analysis, which is let's identify whether this feature is getting adopted. The second is an ad hoc analysis, a random stakeholder. Let's say the sales head is coming and saying, hey, give me the export of how many deals are on stage XYZ from this particular reason. And the third is just a root cause analysis or an open ended analysis where you are like, our revenue in Florida is down. Let's figure out why. And it's equally effective. But at the same time, if the analyst configures it, so everything that you are seeing here where I'm giving it instructions, the analyst can configure it saying that, hey, if the percentage in here implies revenue percentage, right? Like, and then once that configuration is done, as a stakeholder, as a leader, as a chief product, head of growth, even as a CEO for that matter, I can actually come and ask any question and you will see these answers populating. So you can get it verified. If you ever feel like the query is not trustworthy, you can get it verified. If you understand queries, or if you're like even a little bit okay with queries, you can just expand and see the rationale on your own. But this can very well act like your personal assistant or a personal analyst of sorts as well. It's breaking your one question into multiple lines of thoughts, sort of like a whimsical, and then it's putting out everything for you. If it runs into a dead end, if it makes mistakes, it identifies that it made a mistake, it goes back and reruns something. I'll show you some of the examples. So there are other examples as well in this series. You will see some examples of where it makes a mistake and how it goes about doing that. But I hope you enjoyed it. If you have any questions, please let me know. Anywhere you can find me, and I would be happy to answer. Thank you. Bye bye.